So here we need to explain some more solved examples on linear differential equation. So suppose one example is given as solve the differential equation. Solve the differential equation, which is tan inverse y minus x into dy, that is equals to 1 plus y square into dx. So we need to solve means we need to find the general solution of this differential equation. So this we can write it as dx by dy, that will be equal to nothing but tan inverse y minus x by 1 plus y square. So it means if we slightly rearrange it, then we will get dx by dy plus x by 1 plus y square, that is equals to tan inverse y by 1 plus y square. So this is a linear differential equation actually. So this is a this is a linear differential equation of the form which is dx by dy plus p1x equals to q1, where p1 and q1 are functions of y. So here p1 is nothing but 1 by 1 plus y square, and q is nothing but tan inverse y by 1 plus y square, q1 actually. So therefore here in this case the integrating factor would be in sorry it would be integrating factor would be e power integral p1 dy. So that would be e power integral dy by 1 plus y square. So integral 1 dy by 1 plus y square, that is tan inverse y. So that would be e power tan inverse y. So now, and the general solution of this type of differential equation is given as x times the integrating factor, that would be equal to integral q1 into integrating factor into dy plus c. Okay. So therefore the general solution of this differential equation will be, it will be x times e power tan inverse y, that is um, equals to integral tan inverse y 1 plus y square into e power tan inverse y into dy plus c, obviously. So let's say this integral we take it as I. So this is the integral I, which is integral tan inverse y by 1 plus y square into e power tan inverse y into dy. So here if we put tan inverse y equals to t, suppose, then 1 plus y square, then 1 by 1 plus y square into dy, that will be equal to dt. So then therefore this integral, that will be equal to, obviously this is this we can write e power t, then this will be equal to dt. So this will be integral t into e power t dt. So here again we have to use the integration by parts. So here we have to use the Eilert rule. So here it is exponential function, we should take it as the second function, and the algebraic one we should take it as the first function. So this would be t integral e power t dt, then minus integral d by dt of t, and integral e power t dt, then whole integral dt. So this would be t into integral e power t is e power t only. Then minus dt by dt, that will cancel. And this is integral, this is e power t into dt. So this is e power t only. So this is t e power t minus e power t. So the integral is nothing but e power t into t minus 1, which we can write it as e power t, which is tan inverse y into tan inverse y minus 1. So therefore, the general solution, the required general solution of this, of the given linear differential equation is, it is nothing but y, no, x e power tan inverse y in equals to I plus c. This we have taken it as I. So it is x e power x into e power tan inverse y, which is equal to I, which is e power tan inverse y into tan inverse y minus 1 plus c. So now this we can also divide both sides by e power tan inverse y. So then we will get x equals to tan inverse y minus 1 plus c into e power minus tan inverse y. So this is the required general solution. So this is the answer. So we can solve one more example based on this. Suppose if it is asked to find the solution, find the general solution of the differential equation, which is here it is asked to find the general solution of the differential equation, which is y dx minus x plus 2y square into dy, that is equal to 0. So here if we rearrange it, then we will get dx by dy, that will be equal to x plus 2y square divided by y. So that would be, then with this we can write it as dx by dy minus x by y, that is equals to 2y. So this is the, so this is obviously, this is a linear differential equation. This is a linear differential equation of the form which is dx by dy plus p1 into x, that is equals to q1, where p1 and q1 are functions of y. So where p1 is equal to, here in this case, minus 1 by y, and q1 is 2y. And the general solution of this type of differential equation is given as x into the integrating factor, and that is equals to integral q1 into the integrating factor into dy plus c. Okay, where the integrating factor is given as e power integral p1 into dy. So here it will be e power integral minus dy by y. So this would be e power minus log mod y. So this will be 1 by y, obviously. So since y, this we can write it as e power log, this minus will go into the exponent of this. So this will be e power log 1 by y. So this will be 1 by y. Since y, the rule is that e power log, and when no base is there, it means the base is e into some constant, say k, then that will be equal to k. So this is the rule actually. E power log base ek, that is equal to k. So therefore, now we need to find the integral, which is integral q1 integrating factor, which is e power integral p1 dy into dy plus, no, okay, so this will be integral q1, here q1 is 2y, so 2y into 1 by y into dy. So that would be y and y will cancel, so this is simply 2 integral dy, so this is 2y. So therefore, the required general solution, of the given linear differential equation is y no x into integrating factor, which is 1 by y, and that is equals to the I, which is 2y plus c. So that would be equal to x by y equals to 2y plus c, or we can write it as x equals to 2y square plus cy. So this is the required general solution. So this is the answer. Thank you.